Myself, I am Dr. Jntuh. In this class, I am going to discuss with the linked allocation format in a file. As we know that file is an organized collection of a memory. Here, the linked list allocation is one of the most linear method for using a file allocation that is stored in a disk block. In a linked list allocation method, we store the different content of a file that are specified in a contiguous memory allocation. The directory here will comprises of different types of pointers and the different type of issues. For example, we should have a starting file block and ending file block. Each disk block will be allocated and assigned to the particular file or a pointer, which will be having to the next allocation of file. That two will be having the same contiguous memory space. What are the characteristics of linked allocation? Each file will be having a linked list of block. The file will also contain a pointer that will be pointing to the next block. The file will contains the null pointer. External fragmentation has been used here. Free space management, which also be used here whenever a new block is going to be needed for that particular sequence. Reliability is another important feature here. It will improve the efficiency of a clustering block because it can capable of comprising and creating a new number of blocks by using the internal fragmentation concept. So this is a diagram for explaining the linked allocation of a disk space. Here, a file Jeep has been created. Randomly, it has been distributed like that. Okay, for example, it will be started and ending at the point of 25. Randomly, it has been created from a file size of 9 to 25. Okay, so this is how linked allocation has been linearly splitted and divided the block that is randomly splitted and communicated with each other. Moving to the next topic, that is file allocation table. In the linked list allocation, the random access is having some of the disadvantages that we cannot randomly access the file at all the time. Hence, we moved for the file allocation table. Here, the file allocation table, the table has a only one entry for each disk block and it is indexed by a block number. The allocation table needs to be cached in order to reduce the number of bits that has been overridden to it. It can simply access to the file allocation table and we can desirably read it. So this environment can be used in the Windows environment. For example, we can say that the FAT system and pre-NT system are the best example for the file allocation table. So this is the structure of file allocation table. Here the directory name has been created as a test. Here the block table entry has been listed. The first value will store the 217 block number in this value. For example, 618, here is a block file indicating the value has been stored in a new block in the out of number of block. Here the unused block will be indicated by the value 0. Another block will be having some of a value which will be pointing to the address of the particular function. So the advantages of the linked allocation are here the no external fragmentation has been used. Due to this, we can effectively utilize the particular memory. We can increase the size of a file and allocate the file. Chunks of memory has been used in the form of a contiguous form. The disadvantage of this distributed randomly environment has been used. For this, the allocation of the file will be very slower. We cannot directly access the file. We can not support random access file also. Directly access file while traversing, we can access the file. This is a major disadvantage of here. Moving to the next one, that is indexed allocation. Likewise, in the linked allocation, we use the external fragmentation problem. Here in the indexed allocation, we use to solve some of the pointers coming together and store it in a separate location. That location is called as index blocks. Here, each file has its own index block. For example, so this is a logical view. Here, the file will be having holding that particular index block pointed to the disk block. This is how, for example, if CS file is there, it is going to store in a D colon. We can address the file either with the help of a directory name or with the file name. Here, the index table can be listed like that. So this diagram helps us to describe how the index block 19 is related to that particular number. For example, the 19, the file number is having a related to the all the number of file. For example, it having 26, 16, 9, 1 and 14, like that. It having different number of classification here. Moving to the next one, the advantages of a indexed allocation. It will support the direct access. The problem here is external fragmentation. It will overcome the problem of the external fragmentation. Hence, it can compassionate to combine the different number of files. The disadvantage is pointing overhead problem is the major disadvantage here. The entire file can be moved to the index block, which not be correct, because we cannot easily retrieve the file larger files from that. The next classification of the indexed allocation is linked scheme and multi-level index. In the linked scheme, we are having two or more index blocks holding together to the pointer, which will having a pointer value or the address to the next index block will be stored in that particular linked scheme. In the multi-level index scheme, the first level block will be used to point the second level index blocks, which in turn having a disk block which contains maximum number of files. For example, so this is a file is containing the 4096 byte block, which we can accommodate only the 1024 blocks, out of which we does not have any limitation. We can store the file as it is. So next factor is the performance factor. So during the contiguous memory allocation, we can store the file both in a sequential manner as well as in a random manner. So the indexed here used will be having the more complexity. Hence, the performance of the particular CPU is increased and the overhead problem has been reduced. Free space management is another important criteria while considering the file allocation. Here, the free space list has been created by each time the free disk space. It records all the free space and allocates some of our memory to them. To create a file, we will list a free space list there. It will require the amount of space allocated to the new file. Whenever the file is deleted, if the disk space is added to the free space list. Bit vector has been created here. The free space list is implemented as a two form. One is a bitmap, another one is a bit vector. Each block is represented by a 1 bit. If the block is free, then the bit is represented as 1. If the block is allocated, then the bit is represented as 0. So this can be explained with the help of this diagram. If the block is free, means it is represented as 0. Otherwise, it is represented with any other number. So the advantage of this function is it is very, very efficient contiguous memory space is allocated in this disk. Disadvantage is the entire vector has to remain in the same memory. So the congestion will occur between the environment. The free space management linked list is another important approach. Here, the free disk blocks are linked together, pointing to the next free block. The block number here are very, very registered and stored in a separate location, and it are also being used in the cache memory. In this situation, we can explain with the two blocks are there. First block is free, and the block 2 will be pointed to the block 3. For else, it contains the memory address, a location of a particular pointer, and the end of the free list will be having the null pointer. Like that, we can link the list in a frequent manner. So the disadvantage of this list is difficult to traverse the list because it requires more time. So this is an example diagram for the linked free space list on a disk. Here several numbers of blocks have been given. One will be pointed to the other will be having a free list. The traversing list of the elements have been made like this. For example, the blocks are 2, 3, 4. The elements have been pointed to the particular number, and it has been traversing from 2 to 27. Like this, we can moving the address to the next variable. So the next one is grouping concept in the free space management. Grouping is nothing but we are going to store the address of the free block in the first available free block. The first available free block will store the address of the particular register. After that, it blocks the last contained address. So the advantage of this containing address free block can be easily found to the particular file. So we can easily locate the file whenever in the directory. So the next approach is a counting approach. Rather than freeing the particular disk, we can address the particular free block by counting the contiguous memory location. For example, if file is having 10 number of counts, it can be listed. After that, the efficiency of a file has been derived. Efficiency is nothing but the disk allocation which we are going to use, and the directories is also used detected by using the approach. Here the data which we are kept and using this will be make entry into the particular file directory. For example, if I am having a file name as CS in the directory D, I can easily locate a particular file by using this directory algorithm. Moving to the next one, performance. The disk here, the disk cache is used to store the memory. We can increase the performance of a file by using the free behind and read ahead technique. This can use the sequential access of a file and increase the computer performance and store the memory in a virtual disk or a RAM. So this is an example structure of efficiency and performance. Here the file system uses a buffer cache. After that, memory mapped function are used. Input output function by using the read and write operation has been used here. Here the effective utilization of input output function will leads to the allocation of a memory input output in the environment. Thank you.